Hi, I made this Tesla coil and I'm gonna show you some demos. Let's start with a brief description of how this works. Let's start with the regular house outlet with 120 volts AC. It goes to this line filter. Line filter basically protects the house wiring from the electric noise created by the Tesla coil. Without this, the electric noise could go into the house wiring and it could destroy electronics around the house. The 120 volt AC will go through this 10 amp fuse and it goes to this neon sign transformer. The output of the neon sign transformer is 12,000 volts at 30 milliamp, and it goes into this Terry filter. The Terry filter protects the neon sign transformer from the electrical noise created by the Tesla coil. After that, it goes to this main spark gap. The Tesla coil has a primary circuit and a secondary circuit. The primary circuit consists of this capacitor, the capacitor bank, and the inductor, which is this coil. And the primary circuit has a resonance frequency of 240 kilohertz or so. And when the neon sign transformer charges up these capacitors, the main spark gap will short, and that will make the primary circuit to oscillate at the resonance frequency. And the secondary circuit consists of this inductor, which is this big coil. It took about 3.5 hours to wind this thing. And this top load is the capacitor. And the secondary circuit is also tuned to have a resonance frequency of 240 kilohertz. And when the primary and the secondary circuit has the same resonance frequency, the amplification effect takes place, and the top load is charged to about 250,000 volts or so, and the spark will shoot out. Let's move on to the demo. The first case is the nominal case. Nothing attached to the Tesla coil. The second case is with this spring hook. Basically it has a pointy end. If I attach this to the Tesla coil, basically I'm creating a breakout point. Like that. The next demo is with this ladder. It's metallic and it sits close to the ground, so as far as Tesla coil is concerned, it is a grounded object. And when the Tesla coil spark hits a grounded object, you can see that the sparks become brighter. The next demo is with this banana. Banana has a lot of moisture in it, and it has a pointy end, so it also acts as a breakout point. The next demo is with this water bottle. Basically, you can put whatever you want on top of the Tesla coil, but I thought this would be a fun thing to put. The next demo is with the tape measure. You can extend the tape measure like this and then put it on top of the Tesla coil. And you can see the spark coming out from the tip, but you cannot really see it in the video, but the small sparks are also coming out all along the way. So that's kind of cool, but you can't see it really in the video. The next demo is with the light bulb. When Nikola Tesla first invented the Tesla coil, he was working on a way to transmit power wirelessly. So he actually did succeed in doing that. He had a gigantic Tesla coil and on top of a tower or something, and he could light up a bulb like 20 miles from his Tesla coil, but it's kind of inefficient, so it never became practical. But we can see the similar concept here with this small CFL. The next demo is with this piece of wire on the bearing, so it can freely rotate, and the tips are bent kind of in the S shape, so that when the spark shoots out from both tips, it creates a force to rotate this wire.